Tech-ni-shn here again. This is the IF Preamplifier testing. I'm using a 2N5109 transistor. The testing will include gain, return loss, intermodulation and noise figure. The equipment used will be a Siglent SSA 3021X with tracking generator. I'll be using the Easy Spectrum software. Alternatively, a nano VNA could be used for testing the gain and return loss. Also used as an attenuator and return loss bridge. For two-tone testing, I'm using a dual DDS generator, the Rigol DG1062Z. The RF combiner I'll be using for two-tone testing. Alternatively, one can use a return loss bridge. There are miscellaneous coax cables, DC power supply, and I'll be using the Tech-ni-shn for noise figure tests. However, I did use a noise source for some other tests, and both tests gave very similar results. The 2N5109 is unfortunately obsolete. You have to be careful where you buy them from. Alternative devices are the 2N3866 BFW16A or the 2N3553. However, these are also obsolete. I use a PCB from the ham radio store on eBay, and it is a blank etched PCB, and it also includes a relay. I've rewired the PCB so I can switch the amplifier in both directions, and the relay is separately controlled from the amplifier. There is a calculator on the VU2 ESC website where you can calculate the gain, and the return loss is tested with either a nano VNA or the spectrum analyzer. The diagram below shows the setup for measuring gain and includes a 10 dB attenuator to buffer the spectrum analyzer from the IF Preamplifier. The setup below shows the equipment for the return loss, and the IF Preamplifier is terminated in 50 ohms. The amplifier I can switch in either direction, so I can measure either input return loss or output return loss. The second diagram shows the setup for checking the intermodulation. I have adjusted the signal level from the generator, and with the losses in the 2-port combiner and 10 dB attenuator, I've set the output from the amplifier for 0 dBm. From that you can calculate the intermodulation performance by dividing the IMD difference by 2 and adding it to the 0 dBm output. I have also checked the IF Preamplifier for noise figure, and I used the Tech-ni-shn in noise figure mode. I have also separately tested it with a noise source, and the results were very, very similar. Tech-ni-shn here. This is the testing on the IF Preamplifier. I am using the Siglent SSA 3021X spectrum analyzer in the remote mode using Easy Spectrum. I have not connected the preamplifier yet. There is a 10 dB attenuator between the tracking generator output of the analyzer and the RF input. I will now start the tracking generator. The tracking generator is set for minus 10 dBm output, and it is via a 10 dB attenuator. I will now normalize the state of the tracking generator so it reads 0 dB. I will now connect the IF Preamplifier up and we will see the change in gain. At 9 megahertz, that is the IF frequency, the gain is approximately 13.8 dB. Over the HF band, there is a gain change, and at 30 megahertz, if we change the marker to 30 megahertz, the gain is 12.2 dB. This is entirely adequate for a RF amplifier. This is the output of the return loss bridge. It is sitting at minus 15 dB, and this is the losses associated with the return loss bridge. I will now normalize it to 0 dB and then insert a termination on the unknown port. There is approximately minus 40 dB return loss, and at 9 megahertz where it will be used, it is greater than minus 40 dB. This is the return loss of the input of the IF preamplifier, and at 9 megahertz it is about 30 dB return loss, and up to 60 megahertz it is better than 15 dB return loss. This is about 1.5 to 1 SWR at 60 megahertz. By applying a voltage onto the relay, it reverses the circuit. This is the return loss at the output of the amplifier. It is approximately 20 dB. 10 dB of this is due to the output attenuator, so the amplifier return loss is about 12 dB by itself. I will now set up the equipment to do two-tone testing. This is the test for intermodulation. I have two tones at 9 megahertz. One is on 9 megahertz, the other one is on 9.01 megahertz. I have adjusted the level to achieve 0 dBm at the output of the amplifier. The intermodulation of the two tones is at minus 70 dB, and this, if you divide the 70 divided by 2, you have plus 35. This is the third order output intercept if it is added to the 0 dB. At the device, it is probably nearer plus 40 because there is an attenuator between the transformer and the output, so another 5 dB can be added. The device is running approximately 50 milliamps, and this is quite a good level for the device. If you run more current through the device, you will get a higher third order intercept point, but also you will get more heat.